the last thing we're going to look at is we're going to look at how we use a graph to solve a modulus inequality. So something that was in this form here. Okay, so a modulus inequality. So let's look at the example we've been given. We're asked to solve the modulus of 2x minus 1 that's less than 5, and we're asked to solve that graphically. Okay, now how do we do that? Right, step 1 is we have to plot when y equals 2x minus 1. Okay, so we want to solve when y equals the modulus of 2x minus 1. Now, remember already, okay, y can be equal to plus or minus 2x minus 1, okay, because we'll get the same answer. Okay, so let's do it for both. So we'll have two lines. So we have y equals the positive 2x minus 1, which won't change any signs, and then we have y equals the minus 2x minus 1. Now the reason I'm putting it in brackets is because when it's a minus, we need to change the sign. So we're going to have y equals minus 2x plus 1. So we have one line and we have two lines. So we'll just call them line 1 and line 2. The first thing, I suppose, that we need to look at when we're plotting it is if our modulus is less than 5. Okay, let's go to our graph. Okay, we know that a function or inequality has to be less than 5. So it'll be for any value that lies below when this equals 5 or when y equals 5. Okay, so the second thing then we need to do is find where do these two lines intersect. Okay, so where do they intersect? They have the same modulus because they're the same distance from the origin, but where is that point of intersection between the two lines? So we have y equals 2x minus 1, then we have y equals minus 2x plus 1. If we just rearrange these so that it looks familiar to you, so we would rearrange this as minus 2x plus y equals minus 1, and then we'd rearrange this one as positive 2x plus y equals 1. And we have simultaneous equations to find the point of intersection. So we can either get rid of the x's or the y's. So if we get rid of the y's, okay, the signs are the same. It means we subtract one equation from the other. So minus 2x minus a positive, so that would be a minus, gives me minus 4x equals minus 1 minus a positive, so that would be a minus, and minus 1 minus 1 is going to be minus 2. So then x is going to be a half. Okay, when we solve that, it's just simple linear. If we know that x is a half, how do we find what y is? Well, we take one of the original equations and we'll sub it in. So if we have y equals, we replace x with a half minus 1. Well, 2 times a half is just 1. So y is going to be 1 minus 1. So y equals 0. So our point of intersection then is going to be a half 0. So let's go to our graph and plot that point. So it's half 0. So we say it's about there. Okay, so a half 0. So that's where our two lines intersect first. Now what we want to do to be able to plot those lines, okay, because again we need 2 points to be able to plot the lines. We want to find where do those two lines intersect when y equals 5. So where do they intersect with this particular line? So let's go back to our two lines. And so we have line 1, which is y equals 2x minus 1. So that's line 1. And then we have our other line, which is y equals minus 2x plus 1. Okay, right, if we go to our graph, y equals 5 all along here. Okay, so we want to know where does this particular line intersect when y equals 5. So if we place y equals 5, we're going to have 2x minus 1 equals 5. And we'll solve it. So we have 2x equals 6 and x equals 3. So this line will intersect with y equals 5 at the point 3. So the point will be 3, 5. So let's go and plot that point. So we go over to 3 and up to 5. Okay, and then we can plot that line. Okay, so that's going to be our line 1. Okay, so we'll just call that line 1. The second thing we want to do is we want to plot our line 2. So again, we want to see where it intersects when y equals 5. So when y equals 5, we're going to have minus 2x plus 1 equals 5. And we want to solve. So then we're going to have minus 2x equals 4. So then x is going to be equal to minus 2. So that point there then is going to be minus 2, 5. So let's go back to our graph. So we're going to go to minus 2 up to 5. And then we're going to draw this line. Okay, so we'll call this line 2. Now, can we solve our inequality from this graph? Okay, so let's look. We know that our solution set has to be less than 5, because if we look back here, it's when our modulus is less than 5. What values or what will our solution set be? Okay, so if it's less than 5, okay, we know that x is minus 2 when it's equal to 5. Okay, so it has to be for any value that's greater than minus 2. Okay, because if it's less than minus 2, then the value is greater than 5. And if it's minus 2, the value is 5. So it's going to be for any value less than minus 2. Okay, so we're talking about, I suppose, this area enclosed here. Okay, let's go to here. If we plot down, that's a 3. Now we know when x equals 3, it equals 5. So therefore it has to be for any value for x less than 3. Because if it's for any value greater than 3, well then it's going to be greater than 5. And just recall our inequality. We have to solve it when it's less than 5. So it has to be for any value when x is greater than minus 2, because again, if it's equal to minus 2, well then our answer is 5, and we know it has to be less than 5. And then it's going to be for any value then less than 3. And this here is our solution set. And again, we're not told whether x is a real number or a natural number. If we were, we would write that x is an element of a real number or x is an element of a natural number. So our solution set will work for any value where x is greater than minus 2 and any value where x is less than 3.